Picking hardware components out of pure nostalgia means that some of them will be less than optimal. My recent build of an Intel Pentium system was limited to 504 MB of hard drive storage. Join me in the basement as I solve it using 90s solutions. As to why there's a limit, it all comes down to the sum, or rather the combined limitations of both the BIOS and early IDE standard, giving us the limit of 504 MB, which is just too small to have a lot of fun with something like this, because after all it's the age of CD-ROMs and that 504 MB goes very quickly. I'm using compact flash as storage, and as you can see the card is a 4 GB variety. In order to get around that, I'll be installing the OnTrack Disk Manager later in this video. While there are other options available, it's the one I had in the 90s. Except that we now live in the future, so I'm going to use a few modern solutions in order to get that set up and migrate my files over to it. Shown on screen is some magic upscaled footage of me running check disk, both before and after everything is set up. To avoid confusion, I'll be putting this icon on the screen while I'm working with the vintage hardware. First though, we need to make a backup of the compact flash, which is something that's easily accomplished on my modern computer. Here I'm using the Win32 Disk Imager software. Having specified where my backup is going to go and ensuring that the correct device is selected, hit the read button to have the backup created for you. As for the software itself, it can be downloaded from philscomputerlab.com. So let's just grab that one real quick. I'm using the image file as I can drop it onto my Gotek drive. Alternatively, you could write it to an old floppy if that's what you desire. Whichever you chose, just plug it into or insert it into your vintage computer and boot it up. Checking out the README, it spends some time explaining that you have to physically install the hard drive first, boot from the floppy and hit enter for the default switches. If this had been a physical spinning hard drive in the traditional kind, I'm sure there would have been interesting options to look at. While that's loading in, let's switch to Magic Enhanso Vision. Thanks to the backup made earlier, there isn't all that much that can go wrong. I'm just going to go ahead with the easy installation, which is going to format the entire drive, which it would have done with the advanced option anyway. Pick your favorite 90s operating system. And here's the scary part. Hit Alt-C to, well, lose everything. FAT16 means that we have another hard drive limit, this time 2 GB, but it's available in 2 partitions, so EA. OnTrack will now install itself as the first blocks on the hard drive, as well as set up the partitions as specified. After having gone through the motions, we'll just reboot the computer. From this point on, the computer can't boot from normal floppy drives, at least not without starting up from the hard drive first. Without the software loaded, it can't read the hard drive. After the banner, hit space to boot from a floppy. It won't be needed, but I felt like installing DOS 622 anyway, if only so that I can see it function before continuing. Back in the frozen wastes of the modern era, we're going to perform another backup. A word of caution though, Windows 10 won't be able to read the contents of the card anymore, so it won't be mounting it in any traditional way. Just don't hit format and destroy what we've done so far. Specifying a separate file name for this new backup. Win32 Disk Manager will happily create your backup for you, no matter what Windows 10 thinks of the contents. So now you should have two backups, one before OnTrack installation and one after. And now we come to the classic Scooby-Doo moment, the part where the magic upscaling thingy has been revealed to be emulation. Mostly because I had surprisingly weird results trying to film the screen. The software used is PCem. The difference between this and DOSBox, for instance, is that DOSBox emulates the execution environment, but PCem emulates the actual hardware. The program is just downloaded and started from the directory, which won't work, at least until you find an archived version of the firmware needed for various graphics cards, sound cards, and the BIOS itself for many different motherboards. With the software working, we're ready to start setting up a virtual machine using the last backup as a hard drive. Just going to hit new config and give it a name so that I know it's the OnTrack image. Probably didn't make sense to select a socket 7 motherboard with a Intel Pentium 120 processor, but I was just looking for something with a fairly average award BIOS. Mostly DOS and Windows 3.11 won't care as long as we don't go with something completely eccentric. The machine has a Series Logic 5436 graphics card, but I'm just picking something sort of in the same ballpark. For sound, it has a AWE32 and I'm happy that it's available. For the hard drive, I'm going to just look for the backup file that we created last, the one with OnTrack on it. Should show a file select dialog before this one. Every option should be filled out for you, so you don't need to think about it. Booting it up for the first time, it should all look very familiar. We even get the screen that we've come to associate with a flat clock battery. But you should not try to change the battery. Instead, we need to realize the truth. There is no battery. It is just a construct of the emulation. Yeah. Anywho, the machine is now booting up properly. And we see that familiar blue OnTrack banner, you know, the one we mentioned earlier. And DOS 622 seems to work. So we're ready to get moving. And by moving, I mean migrating the files that we had on the old installation. So we need to get the contents out of the first backup that we made. The way we do that is to edit the configuration again, the hard disk drive section. In this case, I will be setting the first backup that we made up as the secondary ID hard drive. We'll just accept the options given and boot up. Skip ahead or stay here for some Xcopy action. Now that all the files have been moved, let's just remove the first backup from the equation so that we don't accidentally mess it up. You're probably too good for such mistakes, but I'm not. For those of you who paid attention during the first part of the video, I showed you a 4 GB card and it was partitioned as 2 separate partitions. This second partition is a logical partition, so it would have been the E drive earlier. But the OnTrack installation didn't actually format it, so we'll need to do that now. If you didn't get an error message here, you might have mounted the early backup image, which we don't want to destroy, at least until we know everything works. So with that done, we have our partitions and we have all our files present. The final piece of the puzzle is where my previous attempts at using OnTrack Disk Manager have failed on retro machines, mainly getting files in and out of the machine. If you're using Linux, then just look up the mount command with on offset. For Windows 10, I can't rule out that there is an easier way to do this, but it's the only one I currently know of. The process is simply to create a VHD file that can be mounted to both the virtual machine and Windows 10, just not at the same time. Follow along as I add the drive to the virtual machine, partition it, and then finally format it. If all that sounds familiar, skip ahead or stay to listen to the music. With the virtual machine shut down, we can then use disk management in Windows 10 to mount a virtual drive, add some files to it. Before the virtual disk image can be used by the virtual machine, we need to detach the drive. This ensures that we're not corrupting the drive by trying to use it in 2 places at once. Now that we have something interesting on the drive, we can use the virtual machine's native tools to move the files about to get them in the correct place. Let's roll some tunes. All that remains now is to write the final disk image back to the compact flash. And that's it. We're ready to see if all our work paid off. It's not exactly quick to get data moved around with the software in place, mainly because of the time taken to back up the card to a file, update the card via the virtual machine, and then write back the image. But if you have a particular fondness for a buggy old motherboard with the limitations in place, then that's what we have to do. Well, then that's it for the moment. Bye.